Hi, I'd like to talk to you today about depreciation and the VDB function in Excel. Here's our case. On July 1st, Nancy paid $600,000 for a commercial building and an additional $150,000 for the land on which it stands. We're going to compute the modified accelerated cost recovery system depreciation for each of the calendar years during which she had the property. So this is an Excel generated depreciation table for the $600,000 commercial building. It excludes the land because land cannot be depreciated. It has a depreciable life of 39 years as defined by the IRS for non-residential real property. So you would see table 11-2 on page 382 for this. So column A is the period. The periods follow the numbering convention in the book. They don't represent years. Period 1 is the first 6 months, so it's from period 0 to time 0 to time 0.5 of the life of the asset. Period 2 is from 0.5 to 1.5, and you'll see how this becomes significant later when we use the function. Column B, that value is taken from table 11-4, and it's a factor recovery 1 year, in year 1, month 7, and that gives us the factor of 0.1177. The factor is acquired from table 11-4 on page 384. The factor is based on the 39-year life and using a mid-month convention. This means that you may only take 1/2 of a month's depreciation regardless of the date the asset was placed in service during the first month. In this example, the asset was placed in service on July 1st, but she only gets 1/2 a month of depreciation for the first month. And then in period 2 and 3, you can see that the depreciation factor changes. All right, and all we're going to do is multiply that factor times the cost basis to get the depreciation amount in column D. That's the manual calculation. All right, so for the purposes of showing you the VDB function, I named the cell that contains the 39 years, I named that cell life, and the 600,000, which contains the cost basis, I named that cell basis. So you can see in my function arguments, I can use the word, and it becomes an absolute reference. So as I drag the function down, it remains fixed on those cells. So it has a double benefit. So here's how the VDB function works. So we're in column E. We're going to use the VDB function for period 1, which is a 1/2 year. So cost, the function argument begin by referencing the cost basis, which is either cell C9, or you can use the name basis if you named your cell that. It is handy for troubleshooting. It makes that function, the function arguments, very intuitive. Salvage, this is going to throw you for a loss here. So the next argument is the salvage value. Strangely enough, regardless of what you enter into the salvage argument, the function uses 0. The function is incapable of accepting a salvage value. Life is expressed in years. Useful life as defined by the IRS. Here, again, I'm going to refer you to table 11-2 on page 382. The organization does not specify the life. It doesn't have anything to do with when you liquidate or when you sell that asset or dispose of that asset. All right, the IRS mandates the life of the asset. So here's our table again. Let's continue. Start period. Think of period 1 as starting at time 0. So if you see that argument, time 0 comes right after life. The next argument is 0. The argument after that, you notice, is 0.5. That's the end period. Think of that as ending at time equal 0.5. The next argument, factor, is optional. The factor represents a percent. Let's think of it that way. So if you put 1 in there, it would be like saying 100%. And 100% represents straight line depreciation. Whereas if you put a 2 or a 200% in there, that's going to represent double declining balance method. Makes sense, doesn't it? 200%, double declining balance. So if you do not enter a value at all for this argument, Excel is going to presume 1. No switch. This is an optional argument also. True means do not switch to straight line depreciation in later years. False, it's kind of a double negative. No switch, false. False means, yes indeed, switch to straight line depreciation in later years when it becomes beneficial. So if you don't enter anything, false becomes the default value. So those are all the arguments in a nutshell. This is, mind you, take a look. We're looking at period 1. Things are going to change in period 2 because period 1 is the first half year. And I'm showing you this because using these arguments in the function in this way, your results are going to match up verbatim with using that factor that you got from table 11-2. So, let's move on. Got a couple pictures here. So, now we're looking at period number 2. So you notice I made a couple changes because now we're talking about full years. Now we're not talking about half a year. We're going to talk about a half a year again when we get to the final time period. All right. So cost, salvage, life, start period, those are all the same. The end period is changed to 1 because now we're talking about a full year. The factor and no switch arguments are the same. So now we can drag all the way through period 39, which becomes the year 38. All right? Because remember, we're starting with 0 to 0.5. All right? So now if you look at the bottom screenshot, you can see that I'm doing the very last time period 40, using the 0.5 again. Because by definition, the first period and the last period are going to be a half a year. All right? That's the way the factor works, so that's the way I'm having the function behave, those arguments. All right. So, here's the last row in our depreciation table, and you can see the total depreciation. The asset cost basis equals the total amount of depreciation, so your asset is fully depreciated. Should work out that way. All right, so let's take a quick look at the double declining balance DDB method and the VDB function. We're going to use the switch option. The function will then switch to straight line depreciation when the double declining balance method falls below the straight line amount. So when it becomes advantageous, this function is going to actually automatically switch for us. All right. So notice that I have the factor as 200%. So that's double the straight line method of 100%. That's where we get the name double declining balance. Notice the no switch is now set to false. All right, that instructs the function to switch the depreciation calculation method when it becomes advantageous. So recall that the first period's calculation, the end period is 0.5. Starting in period 2, we must adjust that. So the function now needs to know the exact period it's in. So it's in time 0.5 to time 1.5. So the start period argument becomes period 2 minus period 1.5. So you can see I'm referencing cell A10, which is period 2. I'm subtracting 1.5 from it. That equals 0.5. So that's where that is going to start. The end period becomes period 2 minus 0.5. So I'm referencing that cell A10. subtracting 0.5. So that makes my end period be 0.5. So can you see that the periods will be 1 year apart on the half year? So that's what we want to happen. Now we can drag the function down the column through all the rows, except for the last row, remember, because we're going to have to calculate that half year on the last one, and we already know how to do that, so I'm not going into that. So let's take a look at the depreciation table. We can see when the function switched depreciation calculation methods. It's going to be easy to spot straight line depreciation because that's constant. So you can see in time period 21, the depreciation calculation switched to straight line because that's at the point where straight line was a higher amount than the double declining balance. So you can also take a look at the very bottom, and you can see that in all our instances, the depreciated value of the asset equals our cost basis, the $600,000. And that's a good thing. That's what we want. All right, well, that's the VDB VBD function and depreciation in a nutshell.